let us do a couple quick problems. And this first one, it's kind of danger. So do you mind, can I just do this problem? I'm not going to think. I'm going to just do it in red. And I think I might be making a mistake. Just go, oh, shoot. It's the natural log of the absolute value of x minus 1, evaluated from 0 to 3. So this is going to be the natural log of 3 minus 1 an absolute value minus the natural log of 0 minus 1. So this is the natural log of 2 minus the natural log of 1. So it just equals the natural log of 2. And we're done. No. We missed something. Where it looks like, hey, just do the freaking integral and just move on. Do you notice the issue? Do you see why this is a problem? Do you see why this isn't going to be allowed? We missed something. We have to know what functions look like. If we don't know what a function looks like, we are screwed. You can't plug in 1. That's what the function is. And we're trying to find the gosh darn area here and here up to 3. Where one of them's positive, one of them's freaking negative. Oh, man. Oh, man. Good thing we noticed. So we got our point. So we have to make certain that when we look at the interval, is there any numbers in between there that might make the denominator equal 0? So, maybe it's not the natural log of 2. Who knows? Maybe it is the natural log of 2. So we can see that we have an issue at 1. 1 is our problem. So we need to break this up into a couple of pieces. We're going to write this as the integral from 0 to 1 of 1 over x minus 1 dx, plus the integral from 1 to 3 of 1 over x minus 1 dx. So now we have it broken into 2 pieces. But as we know, we're not allowed to go towards 1. 1's really bad. So we have to write out our limits. So since this 1 is coming from the left-hand side, you can tell because there's a freaking 0 in there. We're going to say, let's call this, the limit is, I don't know, I'm going to say a goes to 1 from the left. From 0 to a of 1 over x minus 1 dx. Plus the limit, and now we're going to go to 1, so let's call that b goes to 1 from the right. So b to 3 of 1 over x minus 1 dx. All right, now let's solve it. Now let's see what we get. So now we have, what is that? The limit as a tends towards 1 from the left-hand side of the natural log of x minus 1. Evaluated from 0 to a. Plus the limit as b tends towards 1 from the positive side of the natural log of the absolute value of x minus 1, evaluated from b to 3. Now, if we get an infinity anywhere, we can stop. It goes to infinity. Infinity minus infinity doesn't equal 0. Let's see. So we're going to get natural log of a minus 1. Oops, forgot to write my limit. Goes to 1 from the left. Minus natural log of, I'm just going to call it 1. That's 0. Plus ln of 3 minus 1, that's 2. Minus the, limit is b tends towards 1 from the right. The absolute value of b minus 1. What's up? Uh-oh. 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 What's going on here? What's going on here? This isn't good. Right here. When we plug this in, we're going to 1 from the left-hand side. What's 1 minus 1? 0. So the logarithm is tending towards 0. Do you know what a logarithm looks like? It's going down to negative infinity, y'all. That's bad. There's a negative infinity. I'm done. I'm stopping. No more. I'm not even looking at this crap. Go away. I don't care. We got an infinity. Therefore, this diverges. It is a divergent integral. But do you remember at the beginning how I just skipped right past it and I did it in red and came up with a natural log of 2? It's because we missed our asymptote. All right, next problem. Let's do a mellow one and let's keep talking about this. Let's go from 0 to, let's not go to 3, let's go to 1. Let's keep everything mellow. 0 to 1 of the natural log of x. Once again, the natural log looks like this. So we're just finding this area in here. Well, we're coming in from the left. Let's go figure out what that gosh darn area is. Now, what kind of integration technique is this? What do we use when we have a single term? Parts. Hopefully you have this one memorized by now. I know I did as a student. I didn't get a lot of stuff memorized, but I sure as heck knew this one. So this is equal to u times v, so that's what, x ln of x, evaluated from 0 to 1, minus the integral of, v du. X times 1 over x, that's just 1 dx, and we're going from 0 to 1. So that last part, I don't think we have any issues. I think we're pretty good to go on that. But we're not allowed to use the 0, right? Shoot, I probably should have started it off that way. But we're going this way. So you mind if I call it a C tending towards 0 from the right? So we're going to say, all right, so the limit is C tends towards 0 from the right of x times the natural log of x from C to 1. Minus this integral, which is just x from 0 to 1. We don't need anything going on there. So what do we have? Let's check it out. Let's see what we have. So it's the limit as c tends towards 0 from the right-hand side of 1 times the natural log of 1 minus c times the natural log of c. Okay. Minus 1 minus 0. Okay, cool. Cool. Well, this isn't bad. 1 times the natural log of 1, that's just 0. So it looks like we're just left with the limit as c tends towards 0 from the right-hand side of c times the natural log of c all minus 1. So that's 0 times a negative infinity. That's 0 times negative infinity. Natural log of 0 is 0 tends to, or c times, natural log of c is c tends towards 0 from the right-hand side is negative infinity. So we have a 0 times negative infinity. That means do more work, which means we need to use L'Hopital's rule. Do you remember this? Limit of c tends towards 0, 1 over, and we do this crazy trick that we say that c is the same thing as 1 over c. Hey, there it is. There it is. Now we can do L'Hopital's on that. Because up top we have a negative infinity, and down below we have a positive infinity. So let's do L'Hopital's. L'Hopital. So we still have the limit as c tends towards 0 from the right-hand side, and the integral of 1 over c is, or the derivative of 1 over c is 1 over c, and the derivative of 1 over c is negative 1 over c squared. And of course we have our minus 1. So let's flip this thing up. Let's see what's going on, and we have negative c squared over c minus 1. I'm cheating. That's just c. So we just plug in 0. So we have negative 0 minus 1, which is equal to negative 1. And the area was negative 1. L'Hopital's is a thing that's going to happen to y'all. L'Hopital's is useful. So we found that area. It's negative. That makes sense. We certainly should have it be negative. So you wanted to be a STEM major, huh? Okay. You got this. Keep grinding. You'll get it. See.